Hello and welcome to math. Today we're going to learn about surface area and volume of a cone. Okay, so a cone, you guys might have seen a cone before. It looks like an ice cream cone, right? Or a party hat, or a birthday hat, or a traffic cone, right? Those are all types of cones. Okay, so some things you might need to know for cones that you may not know, may or may not know. One thing you definitely need to know is the radius. So all cones have a circle on the bottom of the cone, right? That's the base is a circle. So here's a cone, right? And if I'm looking at this cone, I see that the bottom is a circle, right? So something you need to know is the radius, all right? So the radius would be halfway through the circle to the edge of the circle, right? That's the radius. Something else you might need to know is the height. And the height would be like if I stuck a pencil or something right through the bottom of this and went right to the top, straight how tall it is. If I was going to measure how tall this is from the base all the way to the top, that's our height, right? And the other thing you might see is it's like a cursive L, or sometimes it's like a slanted L, and that's the slant height. And the slant height is the side length. It's the side length down here. So it's the length if you're going to like run up this cone. That's our L, our side length, or our slant height. Okay. So you can see those in here, right? So here's our radius halfway through our circle, right? Our height, like I said, is like straight up through the cone to the point, down back to the base. And here's our L, our slant height, going down the side, right? Those are important to know to be able to surface area and volume of a cone. All right, so let's do surface area first. So here's our formula for surface area. Surface area equals pi r squared plus pi r L. All right, so what does that mean? What does this even mean? What is pi r squared plus pi r L? Well, if you look like on your formula sheet, pi r squared is the area of a circle. And you can see, here's our cone, right? Here's our cone. If I'm finding surface area, I'm finding the whole outside of the cone here, right? So you can see that there's a circle. So we're finding the area of that circle. So that's the pi r squared part. The other part is this part. If I opened it up, I'm finding the area of this part of the cone that wraps around. So that's where the slant height comes in play, right? That comes down. And that's what we're looking at. So that's the two parts of our formula here, pi r squared plus pi r L, right? Okay, so let's see how we can do this. So I'm going to write my formula, pi r squared, and I got to figure out what r is and what L is. So r is halfway through my circle, which is here. So 2 is r. There we go. And then this 6 is my L. That's my slant height. Okay, so I'm going to put an L next to it. There we go. I'm done. Now I can plug it into my formula. Pi r squared plus pi r L, right? Pi we know is 3.14. R is our radius, which was 2, right? And squared plus pi we know is 3.14. My radius is 2. And my slant height, or the length of my side, is 6. So now I would just use order of operations to figure this out. So order of operations would tell me parentheses first, right? Well, there's nothing to do inside parentheses. And then I would do exponents. So I have an exponent here, so I would do 4 here, right? 4 here, and then I can bring this down. And then all I have left is I have multiply. I have 3.14. Oop, I'm going to squeeze that in. 3.14 times 4. And I have multiply here, right? Well, I have to multiply before I can add. So I would do 3.14 times 4. And that would give me 12.56. And then all this stuff over here is all being multiplied. So before I add it, I have to multiply all this stuff. So I have to do 3.14 times 2, which is the radius, times 6, which is our slant height. And that gives me 37.68. All right, so now after I multiplied it, now I can add these two together, right? So I can add these two together, and when I add these two together, I get 50.24. 50.24. All right, so we always want to write our units of measure, and this is measured in feet, so we're going to write feet, all right? And then area, even surface area, still has area in it. Area is always squared. So our answer is A equals, our area equals 50.24 feet squared. All right, so that's kind of a lot of work, right? So, but the good thing is, you can use Desmos, right? And Desmos does an awesome job of substituting and getting you the correct answer, okay? So we can always use Desmos. So if I was going to do this in Desmos, I would first type in my equation here, right? So I would do pi 3.14, and then it says r squared, so I would type r and then squared, right? And then it says plus pi, which is 3.14, and then RL, right? So I can type that in, and then just like how we did with rectangular prisms, all I have to do is figure out what's my radius and what's my slant height, or my side length, right? So my radius here, it says, is 4. So here's my radius, and then this is my L. My 8 is my L, right? That's the side length, the length of the side, the slant height. Okay? So all I have to do now is tell Desmos what R equals. R equals 4, and then enter, and we know L equals 8. And then look at this. Gave us the answer, 150.72. So our answer is 150.72. And then we always want to put our unit of measure, centimeters, and area is always squared. All right, so let's try this next one. This next one says, which is the closest surface area of the cone shown? All right, so it's still surface area, it says. So we're looking at surface area. We can still use that same formula. So I'm going to keep that in Desmos, but I'm going to clear out the R and the L because we're going to have new R's and L's, right? So R is my radius. My radius is halfway through my circle here, right? So that means that this 5 is my radius, and then the L is my slant height or my side length, right? So that is my L, that 13. So I know R is 5 and 13 is L. So I can plug that into Desmos here. R equals 5 and hit enter, and L equals 13. And it gives us 282.6. All right, so which one is the closest, it says. So which one's the closest? Well, I see 282.7. That's really close. So that's got to be our answer, C. All right, so Desmos does a great job. If you don't want to use Desmos, you can always do it by hand, right? But you have to remember, if you do it by hand, you just do order of operations, you do exponents, and then multiply, and then add, right? Where Desmos, you kind of just type in the equation, and you just tell it what R means and what L means, and then it'll do the work for you, which is awesome. Okay, so that's surface area of a cone. All right, let's talk about volume of a cone. So volume of a cone is how, if you're filling up the cone, right? So you're saying how much that cone can hold. So here's my cone. I would be like, if I was going to try and fill this up with liquid, how much liquid could my cone hold? Or if I was at an ice cream store, how much ice cream could my cone hold, right? That's my volume. So the formula for volume of a cone is 1/3 pi r, which is the radius, remember? We just did radius. Radius is halfway through our circle, right? And then h, and h is the height. We talked about the height. Height is when it goes straight up from the base, straight up in the middle to the point of that. That's how tall your cone is. Okay, and then we just plug it in. We use order of operations, and that'll give us our answer for our volume, right? The reason why this 1/3 is here, I got a pretty cool video I'm going to show and combine here. All right. Hopefully YouTube doesn't take me down. But the reason why it's 1/3 is because the volume of a cone is 1/3 of a volume of a cylinder. All right, so if they're the same height and the same radius, you can see the same radius and the same height, it's going to take 3 cones to fill up that cylinder. So here we go. There's one cone. Here's 2 cones. And here's 3 cones. So you can see it took 3 cones to fill up that cylinder, right? So just in case you're curious of why it's a 1/3, that's why it's a 1/3. Cones that have the same height like these do, and they have the same radius, right? The same circumference. They have, the cone is 1/3 of the volume of a cylinder, all right? All right, so let's do one by hand here. I got to figure out what's my radius and what's my height, right? So radius is halfway through my circle, which is here, and that's 6. So 6 is my radius. I'm going to label that R. And then my height is from the bottom of my cone all straight up, straight to the point, right? So that's my height. So 15 is my height. So I'm going to use my formula, 1/3 pi r squared h, right? So now I can plug in what I know. Well, I know 1/3. I know pi is 3.14. And when I substitute numbers in, I always put them in parentheses. R squared is 6. So I'll put 6 in parentheses, squared. And then my height is 15. Okay? So order of operations tells me I have to do this exponent first before I can just multiply all these, right? So 6 squared I know is 36. So now I can take that and I can multiply that 36 to everything else, right? So I can do 3.14 down here, bringing everything down, 1/3, and I can multiply all these across and get my answer of my volume of this cone. So let me clear all this out. 1/3 times 3.14 times 36 times 15. And that gives me 565.2. 565.2. And we always want to put our unit of measure, so that's centimeters. And then volume is always cubed. So it's 565 and 2/10 centimeters cubed. All right. So once again, you guys are lucky. You're the lucky generation of getting to use Desmos, right? So for these ones, let's show you how to do it using Desmos. All right. So if I was going to use Desmos, I'm going to do it the same way I did with surface area pretty much. I'm going to type in my formula, 1/3, and then I'm going to type in 3.14 for pi, and then I'm going to use r squared, and then h, right? So I got to figure out my radius, and I got to figure out my height. So if I look at this cone here, what's my radius? Well, this line goes all the way through, all the way across. So that means that the diameter is 6. Diameter goes all the way across. We only want to know what half of that is. Half the circle, right? So to figure out what that is, I have to do 6 divided by 2. I got to cut 6 in half. And cutting something in half as you divide it by 2. So 6 divided by 2 gives me 3. So my radius equals 3. Right? And my height is going from the middle of my bottom of my circle straight up to the point. And that told me that was 3. So my height is 3. So now that I know that, I can type that into Desmos here, right? So I know r equals 3, and I know h equals 3. And that gives me my answer right here, 28.26. So my volume equals 28.26. We always write our unit of measure, which is meters, squared. Okay? All right, let's try this one. This one says, which is the closest volume of this circular cone? So here's my cone. It's a circle on the bottom, it said. So I got to figure out my height and my radius. So height is how tall it is. Well, that's pretty easy to find. That's just right here, right? That's my height, my 14. Radius is halfway through the circle. They gave me the full distance. So the full distance is 12. That's the diameter. I got to figure out the radius, which is half of that. So I got to do 12 divided by 2. So 12 divided by 2, that's how you cut something in half, is you divide it by 2. And 12 divided by 2 is 6. So my radius equals 6. So I can go back into Desmos, and I can use my handy-dandy calculator. Let's clear this one and clear this one, and right, because we're gonna have a new R and a new H. My R is 6, and my height, my H, is 14. And I got 527.52. So which one is the closest? Well, 527.5. That's the answer. Because if I rounded that, 5 and above, give it a shove. 4 and below, I let it go. 2 is less than 4, so I would let it go and stay at 0.5, right? So 527.5 centimeters, and you see how it says cubed, right? So volume's always cubed. Surface area is always squared, volume's always cubed. Okay? All right, so that's how we find the surface area and the volume of cones. If you ever have any questions, see your teacher. I'm sure they'll be glad to help you, and I'll catch you next time. Bye!